Hearty welcome to all to day two of our national virtual conference on emerging trends in applied mathematics. This PowerPoint session is chaired by Dr. Paul Isaac Sir, HOD, Bharatamada College, Trikakara. For telling about Sir, he is an excellent research guide and he has conducted three minor research projects of UGC, and he has a number of paper publications. Sir has been a resource person for conducting national and international level seminars and conferences and given invited talks. Hearty welcome to this paper presentation session, Dr. Paul Isaac Sir, on behalf of the organizing committee of this conference and Dr. Saju M.I. Sir, our HOD, and the whole faculty of Mathematics Department with IQAC with Santom family. Hearty welcome, sir, once more. Let me remain. Over to Sabu, sir.
Good evening to all. Our first presenter is Soundarya Mohan.
Topic is definite integrals, Riemann sum, and area under the curve. Welcome, Soundarya Mohanan.
Hello, sir.
Okay.
Maximize your window.
Sir, is the screen visible?
Yes.
It's visible. You can maximize it. Full screen view. What is good? Okay then.
Yes. Good afternoon, all. I am Soundarya Mohanan from the Department of Chemistry, St. Thomas College, and I am here to present on the topic Definite Integrals, Riemann sum, and Area under a Curve. Firstly, the abstract. A clinical interviewing method was used to investigate students' understanding of elementary calculus. So, what is elementary calculus? Elementary calculus includes mathematical concepts like limits, derivatives, and differentiation. So, the analysis of responses to tasks concerned with differentiation and rate of change led to detailed data concerning the degree of understanding attained and the common errors and misconception. And as a result, some conclusions were drawn concerning the teaching of differentiation and rate of change, and thereby about
Excuse me,
Riemann sum.
Soundarya.
Yes, sir.
Soundarya, it is not audible. Please switch off your
Audible.
video. Then it is clear.
Audible. Please audible. Audible.
Sir, is it okay now? Hello, sir.
You are audible. You are audible. From the beginning, I am hearing you. No problem. Can you hear me?
Yes, sir.
Then continue.
Now, the research goes as follows. A teaching experiment was conducted in a calculus class to determine what it means to understand definite integrals. And one interesting result was based on students' use of area under a curve as a tool for computing definite integrals. And the results proved that in the problems presented in the study, Students' use of area under a curve was helpful in problem solving only when a deeper level of understanding of the structure behind the definite integral was present. And the main purpose of this research was to examine student understanding of Riemann sums and definite integrals. And these concepts are imperative for students to understand for three main reasons. The first one is that many real-world applications involve functions that do not have an antiderivative that can be expressed in terms of elementary function. So here we have an example for this. Here the example given is the antiderivative of the function f of x is equal to e raised to x squared. Now this function cannot be expressed in terms of elementary function. So what is elementary function? Now these are functions of single variable composed of simple functions. And in this case, the fundamental theorem of calculus cannot be used, and that is when we have to search for an alternative method. And then we have Riemann sum. Riemann sum may not be the most efficient method for approximating a definite integral. Other methods also can be used. They are trapezoid rule, midpoint rule, or Simpson methods, and these are all based on the structure of Riemann sum. So here comes another advantage of using of Riemann sum. An understanding of the structure of Riemann sum helps students to understand these other methods as well. And in all cases, it is possible to imagine definite integral being represented by the area under a curve. Now we have the background. There are several pieces of literature that includes mathematical concepts like limits and derivatives, sequence and series, etc. Although there are several pieces, only two main of them focus on the concept of definite integrals. The first one is the exceptional work of Orton. Now, Orton's study mainly focuses on methods of evaluating definite integrals. As it is common in many calculus classes, many of the definite integral problems in Orton's study involve finding the area under the curve. Now, he mainly discusses the structural and calculational errors that students usually make while finding the area under the curve. Artig, another prominent scientist, also discusses the same. As part of the research, many studies were done, and one such study found that many students could perform routine procedures for the area under the curve, but the students rarely could explain their procedures, and some students even admitted that they didn't really know why they were doing it. And here comes the need for the second literature, that is Thomson's work. Thomson's study focuses on student understanding of the fundamental theorem of calculus. And as a part of his teaching experiment, he even developed and implemented a module to help students understand Riemann sums in a way that develops the fundamental theorem. Now we have the theoretical perspective. According to researchers, the Riemann sum interpretation of the definite integral is perhaps the most valuable interpretation for making sense of integration in applied context, particularly in physics. The term Riemann sum is used here to include conceptions of definite integral as a sum of very small pieces or infinitesimals, such that the infinitesimal pieces are imagined to be a product of the value of some function and an infinitesimal change in the independent variable of the function across a selected interval of integration. Now, what is Riemann sum? The Riemann sum of a real-valued function f on the closed interval ab is defined as the sum of f with respect to the tagged partition of closed interval ab. And the equation is as follows. As we can see, every term of Riemann sum denotes the area of a rectangle having length or height f of ti and rect xi plus 1 minus xi. And hence, the Riemann sum gives the area of all the rectangles and thus the area under the curve within the closed interval AB or definite integral. Now moving on to our main topic, the application of Riemann sum. In general, a Riemann sum is an approximation of a region's area obtained by adding up the areas of multiple simplified slices of the region. It is applied in calculus to formalize the method of exhaustion used to determine the area of the region. And this process yields the integral which computes the value of the area exactly. So the main application of Riemann sum is that it computes the exact area. Now the real life applications. These are the way a computer computes the integral of some numerical data. For instance, the data from an accelerometer which yields the speed of an object and ultimately the position. They are also used in pure mathematics to express some kind of supremum of sums as integral. They are also used in various other fields like differential calculus, integration, and even in physics problems. They can be used in partial differential equations and representation of functions by trigonometric series. It is also used for the measurement of distance traveled by some object because we can easily retrieve the average velocity of the journey and total time by the velocity versus time graph. And the distance traveled is represented by the area under the curve. Now it's time to conclude. Integration is an easy way to find the area under a graph when you are given a function. However, when you have a set of data points that do not form an obvious equation for a function, integration becomes harder because we do not have an equation to integrate. And in such situation, we use Riemann sum. Now these are the references I used. And that's it. Thank you.
Okay, thank you. What is an elementary function, Soundarya?
Sir?
What is an elementary function?
They are functions of single variable which are composed of simple functions.
Can you give an example?
This one, f of x is equal to e raised to x square.
There are more simpler functions than e raised to x, which are elementary. Okay, good. Your presentation was very nice. Okay, thank you. Next one.
Thank you, sir.
Thank you, Soundarya. Next presenter is Sujesh Arikara, research scholar, St. Thomas College Autonomous, Thrissur. His topic is Basics of Image Processing and Image Compression. Welcome, Sujesh Arikara. Please share the screen.
Hello, good afternoon. Hello, am I audible?
Yes, you are audible.
Okay. I'm Sujesh Arikara, research scholar, Department of Mathematics, St. Thomas College, Autonomous, Thrissur. And my topic is MATLAB applications in image processing. MATLAB is basically a software. MATLAB is the acronym for Matrix Laboratory. MATLAB, developed by the MathWorks Inc., is a system of computer algebra, numerical and graphical designed for professional use in solving problems that requires mathematical methods. Now, what is an image? For a mathematician, an image is nothing but a matrix. Hard to believe? I will consider the matrix. Consider this matrix. I'm saying that this is an image. Still, if it is hard to believe, that corresponding matrix can be zoomed out to form this image. This is the well-known image, Felix the cat. This is the MATLAB code for implementing, and that is the output. Colors in MATLAB are coded with 3 numbers, red, green, and blue, usually called RGB values. Now, we have seen the black and white version of Felix the cat. This is the colored version of Felix the cat. What is meant by image processing? Image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. Now, its applications. We are familiar with cropping an image. Suppose we need to crop the selected region. This is the code implemented, and that is the output we get. Now, the next application is resizing an image. This is the MATLAB code implemented, and that is the output. We are resizing the original image by 50%. Now, rotating an image. If you want to rotate an image by 75 degree, this is the MATLAB code used, and the corresponding output is given. Next application is creating a collage. This is the MATLAB code used, and this will be the outcome. The first one is the original one. This is the cropped version. This is the resized version, and this is the rotated version. Next, how to enhance an image using MATLAB. This is the code used, and this is the original image, and this is the enhanced image. If we look closer, the color of the enhanced image is much blacker in quality, and it is the enhanced image. We are all familiar with editing in mobile and applying filters and all. Those transformations can be done in MATLAB also. This is the MATLAB code used. RGB to gray is the conversion from a colored image to grayscale. And infilter BH is blurring of image. This is the original image considered. This is converted into grayscale, and grayscale is blurred, and the original image is highly blurred. We can also detect a phase using MATLAB. This is the code implemented. We can not only detect a face, but also face features. For example, we can detect a mouth. Consider this image. In this image, we are going to detect the face and also the mouth. This will be the outcome of face detection code used earlier. This one. And this is the mouth detected from the picture using MATLAB. Now, how to add two images in MATLAB? This will be the code implemented, and the results are given these two. This is the colored version, and this is the grayscale version. Further applications are face features detection. Other than detecting a face or mouth, we can detect other facial features like eyes, lips, etc. Color thresholding, edge detection, OCR in text and natural images. OCR is familiar to us. We can see them in the band application, cam scanner, and many other applications like that. Detecting cars in traffic videos, identifying round objects. These are some applications of image processing using MATLAB. Thank you. Are there any doubts?
Any question? Spectators, audience, any question?
Sir, we can see the comments in comment box.
Comment is given only audible. That is what I see here. So next one.
Okay, thank you, Sujesh Erikera. Next presenter is Sanila Mary Davis, Department of Mathematics, St. Thomas College Autonomous Thrissur. Her topic is nanofluids and applications. Welcome, Sanila Mary Davis, for the presentation.
Next presentation, please.
Sanila Mary Davis, please present.
Hello.
Okay. Audible.
Are you a research scholar? Are you a research scholar or a student? Can you hear me?
Yes.
Are you a research scholar or a faculty?
No, I'm a teaching student.
Sanila Mary Davis, please present.
Faculty ആണോ അതോ സ്റ്റുഡന്റ് ആണോ?
Student. She is a student. MSc student.
MSc student. Okay, please continue your presentation. Start your presentation, please.
Can you see anything?
Not visible your presentation. Please share the screen.
സാബു സാറ് അവിടുത്തെ ഫാക്കൽറ്റി ആണോ അതോ
Yes sir. ഞാൻ അവിടുത്തെ ഫാക്കൽറ്റി ആണ്.
എത്ര നാളായി സെന്റ് തോമസ് വന്നിട്ട്?
ഞാൻ 7 വർഷമായി.
സിസ്റ്റർ ജോലിയൊക്കെ എത്ര വർഷമായി? ഒരുപാടായോ?
ജോലി സിസ്റ്റർ എനിക്ക് ശേഷമാണ് ജോയിൻ ചെയ്തത്. 7 വർഷത്തോളമായിരുന്നു.
ഡിപ്പാർട്ട്മെന്റിൽ ഇപ്പൊ അസോസിയേറ്റ് പ്രൊഫസറായിട്ട് സാജു സാറ് മാത്രമേ ഉള്ളൂ?
ഇല്ല ഇപ്പൊ മാത്സ് ഡിപ്പാർട്ട്മെന്റില് അസിസ്റ്റന്റ് പ്രൊഫസേഴ്സ് ഉള്ളൂ. അസോസിയേറ്റ് ഇല്ല ആരും.
വിജിമിസും ആയിട്ടില്ല അല്ലേ?
ഇല്ല ആരും ആയിട്ടില്ല.
2009 വന്നതായിരിക്കും വിജിമിസ് അല്ലേ?
അതെ.
ചക്രവർത്തി സാറിന്റെ സ്റ്റുഡന്റ് അല്ലേ വിജിമിസ്?
അതെ ചക്രവർത്തി സാറിന്റെ സ്റ്റുഡന്റ്.
Please start your presentation.
Please share the screen. Sanila Mary Davis.
Hello, sir.
Okay, present. Now present. Is any network issue for the... Okay, she has some network issue. Next presenter is Lini Wilson, Assistant Professor, Department of Commerce, St. Thomas College, Autonomous, Thrissur. Her topic is Role of Mathematics Tools in Business Decision Making. Welcome, Lini Wilson.
Good afternoon, sir. Good afternoon, all. Myself, Lini Wilson, Faculty, Department of Commerce, St. Thomas College, Thrissur. My topic is Role of Mathematical Tools in Business Decision-Making Process. Moving to introduction. In every field, in order to achieve objective, good decision-making process is required. Decision-making is the process of selecting the best alternative from the available alternatives. Scientific decision-making process involves the use of mathematical tools like linear programming, algebra, probability, etc. Business organizations are using mathematical tools in the areas of forecasting, production, sales, inventory management, accounting, and financial analysis, etc. In every aspect of business, one feels helpless without mathematics because business deals with monetary transactions, and this money element makes it extremely to have sufficient knowledge about the basics of mathematical calculations. So in this purview, this study analyzed the role of mathematical tools in business decision making, and it is a descriptive study based on secondary data. So first we have to look at what is decision making process. Decision making is a key part of manager's activity. According to Peter Drucker, whatever a manager does, he does through decision making. Decision making is not a separate function of management. Rather, it is present in every managerial functions like planning, organizing, direction, and control. So decision making is the selection of best possible alternatives from among the various alternatives for the solution of a given problem. So main steps in decision making process is we have to identify the problem or opportunity, then we have to determine our objective, then we have to identify the alternatives and evaluate them and choose the best alternative and implement the alternative and make maintenance or follow-up decision. Next, we are going to look at the main part, application of mathematics in business decision making process. The stream business mathematics reveals the basic applications of mathematics in business firm. Business involves the buying and selling of goods in order to earn profit. It uses mathematics to record, classify, summarize, and analyze the business transactions. So, mathematics is used by commercial enterprises to record and manage the business operations such as elementary arithmetic involving fractions, decimals, percentage, elementary algebra, statistics, and probability. Nowadays, business management is using advanced mathematics such as calculus, metrics, algebra, and linear programming. Practical applications includes checking accounts, forecasting the sales, price discount, markups, markdown, payroll calculation, simple and compound interest, reducing wastage of resources, etc. Into the detail, first metrics. Matrix is an arrangement of numbers into rows and columns, as total cost, revenue, supply, demand, and population are all related with a system of linear equations. The Leontief model production equation in input-output analysis uses metrics to predict what happened to an economy when final demand changes. When you are faced with multiple choices and several variables, a decision matrix can clear up confusion and highlight considerations that may factor into the final outcome. This quantitative method can remove emotion as well as confusion to help you lead your business to success. Unlike a simple list of pros and cons, a decision matrix allows you to place importance on each factor and weigh them accordingly. Next, operation research. Operation research is the application of scientific methods, techniques, and tools to problems involving the operation of a system so as to provide those in the control of the system with optimum solution to the problems. Operation research is an analytical, logical, systematic method of problem solving and decision making that is helpful in the management of organization. In operation research, problems are broken down into basic components and then solved in defined steps by mathematical analysis. Analytical methods used in operation research include mathematical logic, simulation, network analysis, queuing theory, and game theory, etc. Business organization uses techniques on operation research like inventory control model, waiting line model, replacement model, allocation model, linear programming techniques, etc. to derive solutions for various problems related to stock keeping, maintenance, transportation, assignments, and product mix selection. Into detail, in transportation decision, various centers with their demands are given and various warehouses with their stock positions are also known. Then, by using linear programming technique, we can find out most economical distribution of the products to various centers from various warehouses. In product mix selection, decision operation research techniques can be applied in determine best mix of the products for a plant with available resources so as to get maximum profit or minimum cost of production. The technique of operation research can be applied for assignment of different personnel with a different aptitude to different jobs so as to complete the task within a minimum time. Many financial decision-making problems can be solved by using linear programming technique. Algebra. Algebra is a branch of mathematics dealing with symbols and the rules of manipulating those symbols. In elementary algebra, those symbols represent quantities without fixed values known as variables. Mathematical applications are needed to study accounting. It incorporates successful exploration of numerical, geometrical, logical relationships. Mathematics benefit accountant in comparison. Mathematical formulas help business and commerce to compare income, cost, expenses, and profit. The various formulas are derived using various percentages, ratios and equations. The various ratios are derived such as inventory turnover ratio, profitability ratio, debt turnover ratio, debt equity ratio, etc. Mathematics is helpful in deriving accounting equation. The basic idea in accounting is the total wealth of business is called asset. There are two possible claims on asset called liabilities and claim. By using mathematical equation, asset equal to liabilities plus capital, accountants use mathematics in order to arrive the total cost and taking decision regarding manufacturing or buying the product. The total cost formula for business is T is equal to A plus BX, where T is total cost, A is fixed cost, B is cost per unit produced, and X is the number of units produced. Also, profit also determined by subtracting total cost from total revenue and helps in analyzing the financial health of business, and prices are determined by adding some markup to cost. So accountant use addition and percentage to determine the price of product. Calculus. Calculus is a study of how things change. It provides a framework for modeling system in which there is a change and a way to reduce the predictions of such models. In business, we come across many such variables where one variable is a function of the other. For example, the quantity demanded can be said to be the function of price. Supply and price or cost and quantity demanded are some other such variables. Calculus helps us in finding the rate at which one such quantity changes with respect to the other. Managerial analysis in economics and commerce is the most direct application of differential calculus. Differential calculus also helps in solving problems of finding maximum profit or minimum cost, etc. While integral calculus is used to find the cost function when the marginal cost is given, and to find total revenue when marginal revenue is given. Probability. Future events are uncertain, and to predict this uncertainty, probability is an effective tool to forecast sales, scenario, future returns, and risk evaluation in the business world. Before introducing the product, team of market research analyze data relating to production, income of consumer, taste, preferences, habit, price policy of competitors. By using various statistical techniques, we can collect and analyze the data in the field of economy by using statistical method. Probability theory serves as a useful tool for decision making, estimating number of defective units, sales expected, and also in business policies. The application of profitability theory in small business was examined to find the implications and restoring the gap between the rich and poor through better and informed decision. In a nutshell, statistics and probability are very useful in taking various decisions relating to material production, finance, personnel, and marketing in an industry. So, using statistical data, we have many benefits. It simplifies the decision-making process. It helps in creating a decision model. It helps in testing and interpreting the data. The mathematical base gives the data more importance. Modifications become easier. So I conclude, the mathematical tools and methods become crucial part of business organization. Application of mathematics become necessary from business decision making. Mathematical tools application is evident from buying or estimating the cost of product to the end, sales and earning profit. Mathematical formula help business to do financial analysis using ratio, percentage, equations, etc. The objective of minimizing cost and maximizing profit is achieved through linear programming and calculus. The estimation of future return and profitability is done through probability distribution. It also helps in sales forecasting and risk evaluation. Metrics plays important role in variety of solutions for consumer relationships and logistic management. Statistics help in collection, presentation, and analysis of data to arrive at conclusion. So we conclude that mathematical tools plays an important role in business decision making. Mathematics is an important element in decision making process of all organization. Thank you, sir.
Hello, sir. Your mic is mute.
Paul Isaac sir, mic is mute.
Okay. Can you hear me?
Yes, sir.
Okay. Are you interested in mathematics?
Yes, sir.
From where did you get so many branches of mathematics?
Uh,
Information about so many.
I am a commerce faculty. We have mathematics related subjects like QT, numerical skill. So we have some base about this.
Okay, good. Any questions from the audience part? Any questions? Any questions from audience? No.
No questions.
Okay, then pass over to the next one. Okay, thank you. Congratulations. Thank you. Congrats.
Thank you, Lini Wilson. Next presenter is Soumya K, Department of Mathematics, St. Mary's College, Thrissur. The topic is Introduction to Fuzzy Rees IG module. Welcome, Soumya K.
Good afternoon, sir, and good afternoon to one and all present here. Myself, Soumya K, Assistant Professor, Department of Mathematics, St. Mary's College, Thrissur. The topic I am going to present is Fuzzy Rees LG submodule. Sir, is my screen visible?
Yes.
So, abstract. A fuzzy Rees LG submodule of a Rees LG module is defined and properties are listed. A convex fuzzy Rees LG submodule is also defined and properties are studied. So, introduction. Fuzzification of crisp algebraic structures always leads to structures having many practical applications. Fuzzy vector spaces are studied by Katsaras. Fuzzy vector lattices are discussed by Samuel and Labus. Fuzzy G modules is introduced by Sherry. Fuzzy lattice-ordered G modules is studied by Ursula. And in this paper, a fuzzy Rees LG submodule is introduced based on the Rees LG module defined by Soumya and Sister Maggie Jose. So preliminaries, first definition, let L be a poset and x comma y belongs to L are such that x less than or equal to y. Then by an interval, we mean the set of all z belongs to L such that x less than or equal to z less than or equal to y. A non-empty subset C of a poset L is said to be convex if closed interval a comma b is a subset of C for all a comma b belongs to C with a less than or equal to b. A lattice L is a poset in which both minimum and maximum of two elements exist in L.
So one doubt. Here you define poset, and in poset you are defining the interval.
Yes, sir.
It not be numbers.
Yes.
It not be numbers.
Sir, pardon, sir.
It not be numbers. You are defining interval in poset.
Yes, sir.
And partial set need not be numbers always.
Okay. Elements for two elements x and y in L.
Okay.
Can I continue, sir?
First, you continue.
Yes. Thank you, sir. Next definition, a non-empty subset capital M of a lattice L is said to be a sublattice of L if x minimum y and x maximum y belongs to M for all x comma y belongs to M. Next definition, let G be a group and less than or equal to be a partial order defined on G. Then G is said to be a lattice ordered group or an L group if G less than or equal to is a lattice. And if G1 less than or equal to G2 implies x star G1 star y less than or equal to x star G2 star y for every x comma y comma G1 G2 belongs to G. Next definition, let G be an L group. The positron of G is the set of all G belongs to G such that G greater than or equal to E, which consists of all the positive elements, and G minus is the set of all G belongs to G such that G less than or equal to E, which consists of all negative elements of G. We next define G plus and G minus for an element G belongs to G. By G plus, G plus we mean G maximum E, which belongs to G plus, where E means the identity element of the group G. G minus is equal to G inverse maximum E, which also belongs to G plus. Hence, mod G equal to G maximum G inverse, which is equal to G plus star G minus, and it also belongs to G plus. By star, we mean the binary operation defined on G. Next definition, let G be an L group and P equal to G plus be the positive cone, then for every G belongs to G, G, P, G inverse equal to P. Next definition, a real vector space V is an ordered vector space if it satisfies the following conditions. If x less than or equal to y, then x plus z less than or equal to y plus z. If x less than or equal to y, then lambda x less than or equal to lambda y for every x, y, z belongs to V, and for every lambda greater than or equal to 0, which belongs to R. A vector lattice or a Rees space is an ordered vector space, which is also a lattice.
So in that vector space, there should be an ordering.
Yes, sir.
X less than or equal to y. To write x less than or equal to y, there should be an ordering.
There should be an order, yes.
If there is an ordering, then why you write V is an ordered vector space?
V is actually a poset, and it is a vector space, and it is called a vector space, ordered vector space, if that order defined on V satisfies, or it should compatible with.
Okay.
Yes.
Instead of writing a real vector space, you write a vector space which is a poset is an ordered vector space. And only you can talk about that in relation there. Except
Okay, sir. Okay, sir. Thank you. Example, Rn, Euclidean space Rn is an example for a vector lattice or a Rees space. Under the product order, by product order we mean x less than or equal to y for two elements x comma y belongs to Rn. Xi less than or equal to yi for every I equal to 1, 2, 3, etc. to n. And by supremum and infimum of these two elements x and y, we define x maximum y equal to xi maximum yi, and x minimum y equal to xi minimum yi for every I equal to 1, 2, 3, etc. to n. A vector sublattice or Rees subspace of a vector lattice is a vector subspace which is also a sublattice. Next definition, let G be an L group and a Rees space E is said to be a Rees LG module if the group action G on E, which is denoted by G circle X, belongs to E for every G belongs to G and X belongs to E, and has the following properties. The first one, E circle X equal to X. Second one, G star H circle X equal to G circle H circle X. Then G circle Rx plus Sy equal to R into G circle X plus S into G circle Y. The next one, mod G circle X minimum Y equal to mod G circle X minimum mod G circle Y. Mod G circle X join Y equal to mod G circle X join mod G circle Y. G minimum H circle mod X equal to G circle mod X minimum H circle mod X. G join H circle mod X equal to G circle mod X join H circle mod X for every G H belongs to G, X comma Y belongs to E, and R comma S belongs to script R, the set of all real numbers. Next definition, let E be a Rees LG module. A vector sublattice or a Rees subspace F of E is said to be a Rees LG submodule or RLG submodule of E if F itself is a Rees LG module under the same action of G as that on E. For example, R2. R2 is a Rees LG module under the action of R plus the set of all real numbers where the group action is defined by R circle X comma Y equal to Rx comma Ry for every R belongs to R plus and XY belongs to R2. Next, let us define fuzzy Rees LG submodule. The definition is a fuzzy subset rho of a Rees LG module E is said to be a fuzzy Rees LG submodule or a fuzzy RLG submodule if it satisfies the following conditions. The first one, rho of Rx plus Sy greater than or equal to rho of X minimum rho of Y. Second condition, rho of X minimum Y greater than or equal to rho of X minimum rho of Y. Next condition, rho of X join Y greater than or equal to rho of X minimum rho of Y. Rho of G circle X greater than or equal to rho of X for all G belongs to G and X comma Y belongs to E, R comma S belongs to script R. The Euclidean plane R2 is a Rees LG module. If we define a fuzzy set rho in R2 defined by rho of x1 comma x2 equal to 1 if x1 equal to x2 and 0 otherwise, then rho is a fuzzy Rees LG submodule. Here, next theorem, let rho be a fuzzy Rees LG submodule of a Rees LG module E. Then for every x belongs to E, the following conditions hold. Rho of 0 will be greater than or equal to rho of x. Rho of x plus greater than or equal to rho of x. Rho of x minus greater than or equal to rho of x. Rho of mod x greater than or equal to rho of x. Next theorem, let rho be a fuzzy RLG submodule of a Rees LG module E. Then for every alpha belongs to left open 0, 1, the level set rho alpha defined by rho alpha of x equal to set of all x belongs to E such that rho of x greater than or equal to alpha is a RLG submodule of E if and only if rho is a fuzzy RLG submodule of E. Next theorem, let E be a Rees LG module, then a non-empty subset capital F is a Rees RLG submodule of E if and only if the characteristic function of F is a fuzzy RLG submodule of E. Next theorem, let E be a Rees LG module and rho be a fuzzy RLG submodule of E. Then for K belongs to R plus, the fuzzy set K rho defined by K rho of x equal to rho of Kx is a fuzzy RLG submodule of E. Next is a definition. A fuzzy subset rho of a Rees LG module E is said to be a convex fuzzy Rees LG submodule or a convex fuzzy RLG submodule of E if rho of z greater than or equal to rho of x minimum rho of y for every x comma y belongs to E with x less than or equal to z less than or equal to y. Next theorem, let rho be a fuzzy RLG submodule of a Rees LG module E. Then for alpha belongs to left open 0, 1, the level set rho alpha defined by rho alpha for x equal to the set of all x belongs to E such that rho of x greater than or equal to alpha is a convex RLG submodule of E if and only if rho is a convex fuzzy RLG submodule of E. Conclusion in this paper, a fuzzy Rees LG submodule and a convex fuzzy Rees LG submodule of a Rees LG module are defined and properties are listed. The idea can be extended to further research in this field. These are my references. Sir, I am happy to mention that 2 of your papers have been used for the reference work and it has contributed much for the development of my paper. Thank you, sir.
Is there any questions from the audience part? Is there any questions? The audience part, is there any question? No.
Okay.
Then you have just started your work or?
No, sir. No, sir. I'm in the extension period. 6 years over.
Years over. And
Yes.
papers published already?
Yes, sir. 2 papers are published.
One question. What is the structural difference between a module and a vector space?
Module answer.
What is the structural difference between a module and a vector space?
Vector spaces are defined over a field F, whereas modules are actually defined over a ring, most commonly commutative ring R.
So what difference occurs in their structures? You mean every vector space is a module?
Yes.
ശരിയല്ലേ? വെക്ടർ സ്പേസ് module അല്ല. എല്ലാ മോഡ്യൂളും വെക്ടർ സ്പേസ് ആവണമെന്നില്ല.
ഇല്ല.
എന്താണ് സ്ട്രക്ചറൽ ഡിഫറൻസ് എന്താണുള്ളത്? അതൊന്ന് ആലോചിച്ച് നോക്കുള്ളൂ കേട്ടോ. കണ്ടുപിടിക്കാം.
Yes. Thank you, sir. Okay.
ഒരു ക്വസ്റ്റ്യൻ കൂടെ ചോദിക്കട്ടെ. അവിടെ R2ന്റെ ഒരു Rees LG submodule ഡിഫൈൻ ചെയ്തല്ലോ. If x equal to y, then value is 1, otherwise 0.
Yes, sir.
അതൊരു ഓർഡിനറി submodule ആവും. Let be R2 വെക്ടർ സ്പേസ് ആണല്ലോ.
It is a line actually passing through the origin. So it is actually a subspace. It is a subspace of R2. Definitely, it is a subspace.
Okay, thank you. Thank you very much.
Thank you, sir. Thank you for the suggestions and all. Thanks, sir.
Thanks a lot, Soumya.
Okay. Next presenter.
Next presenter is Saravanan B, research scholar, St. Thomas College, Thrissur. His topic is a review on boundary layer flow of a nanofluid past a stretching sheet. Welcome, Saravanan sir.
Thank you, sir. Thank you. Namaskaram, sir.
Namaskaram.
Good afternoon, sir.
Good afternoon.
Sir, today my review paper is on boundary layer flow of a nanofluid past a stretch sheet, authored by V.A. Khan and I. Pope. My name is B. Saravanan, research scholar in St. Thomas College, Autonomous, Thrissur, and I'm an assistant professor in NSS College, Nineveh. Now I'm going to the preliminary of this topic. The first one, what is a basic fluid, base fluid? These are nothing but normal fluid like engine oil, water, ethylene glycol, glycerin, etc. And here more specifically we are dealing with the nanofluids. So what is nanofluid? Nanofluid is nothing but the fluid in which we have a small particle suspension. That is small particle in the sense it is a nanometer size solid particles which we are putting in the base fluid. Okay, so then only we can able to say it is a nanofluid. So this total review is on this nanofluid only. Okay, so the objective of this review is to study the development of a steady boundary layer flow and the nanoparticle fraction over a stretched surface in a nanofluid. So this study is based on what are the parameters is nothing but the solution will be analyzed based on Prandtl number. Prandtl number is nothing but it is nothing but the molecular diffusion of momentum over the molecular diffusion of heat. Similarly, the next parameter which we are using is Lewis number. Lewis number is nothing but the thermal diffusivity divided by mass diffusivity. And the third one, Brownian motion parameter. Brownian motion means it is a irregular motion of the suspended particle. Here the suspended particle is nanofluids, nanoparticles. Okay, so this is the parameter which is carrying out the irregular motion of the nanoparticle. Okay, the fourth one, a thermoporous parameter. Thermoporous parameter is nothing but is dealing with the movement of the particle in the temperature gradient. That means the temperature is whenever it is increasing or decreasing, how the movement, that parameter is thermoporous. Okay, then the next two, Sherwood number and Nusselt number, it is dealing with the measurement of mass transfer and heat transfer. Okay. Next, we enter into the actual topic. Actual topic is we have a wall structure. Within in that we have a small nozzle is there. So within that we are pouring the, or we are pressing the nano fluid. Okay. In the right hand side we have a stretched sheet. On that the nano fluid is passing through. Okay, the boundary is shown there. So for that we have a set of equations. In this set of equations we have a equation of motion is there, and the next two set of equations are conservation of mass, and the next two are a conservation of energy. Okay, so along with that they are given the boundary condition also, and here we are stretching the sheet in only unidirection, that is in x direction alone. So you see this in this diagram itself, we can able to say that the plate is stretched in the x direction. Okay, so that is why we are having here u is equal to, in the boundary condition we have u is equal to a times of x. Okay, So this system, we are solving it, and we are solving in such a way that using the MATLAB functions. See, numerically we are solving it. The reduced governing equation are solved using MATLAB function. The effect of various parameters of the velocity, temperature, and concentration profile are analyzed using the graphs. Then a simultaneous effect of parameter on heat transfer rate is scrutinized using two-dimensional surface flow. Okay, so one by one we will get the results we are got using the MATLAB function. First of all, you see here we have 6 parameters we have mentioned. In that, according to the percentage of the nanoparticles and the temperature increase or decreasing, you see thermoporous parameter and Brownian motion parameters are increasing whenever temperature is increased, as well as the percentage of nanoparticle is increased. Okay, that is why they are the arrows moving in the upward direction. Okay, that is one of the result we are getting. Then in the second case, you see they are considering the Prandtl number, then thermoporous parameter and Brownian motion parameter are all constant. Now in that case, you see Lewis number is goes on reducing. Okay, so that is the second observation we are getting. The same way, the Brownian motion parameter is going on reducing when I consider the other 3 parameters: Prandtl number, Lewis, and thermoporous parameters are constant. Okay, this is the next observation we have made. The next observation is we are connecting thermoporous parameter and Sherwood number. So in that case, you see Brownian motion parameters goes on increasing. Okay, the other observation we can able to make in between thermoporous parameter and Sherwood is Sherwood parameter is decreasing as thermoporous parameter is increasing. Okay, that is the first diagram shows. The second diagram, you see, the second diagram, as thermoporous parameter is increasing, Sherwood parameter is also increasing, but arrow says in the downward direction. That means Brownian motion parameter is decreasing. Okay, that is the second observation we have made. The third diagram, only the thing is we can able to say is Brownian motion parameter is decreasing, but we cannot able to compare thermoporous parameter and Sherwood number. Okay, the last one, you see Brownian motion parameter is decreasing, but when compared to Sherwood number and thermoporous number, Sherwood number goes on increasing, isn't it? So that is a 4 observation, pretty important observation we are making. So as a conclusion with this, nanoparticle temperature distribution exhibits a positive impact on Brownian motion parameter NB and thermoporous parameter NT for the constant value of Prandtl number and Lewis number. Second observation we have made is nanoparticle concentration distribution exhibit a negative impact on Lewis number LE for the constant value of Prandtl number and Brownian motion parameter NB. And the last one is nanoparameter concentration distribution exhibits a negative impact on Brownian motion parameter NB for the constant value of Prandtl number, Lewis number, and thermoporous number. Okay, so this is the conclusion. And some of the applications we have is cooling and drying of paper and textiles, glass fiber productions. In all these things, we can able to have an application for this. Cooling bath, then extrusion. That means extrusion. We are that is giving force to make a die. Okay, extrusion process in plastic and metal industries. So in that also they have the application. Then boundary layer along liquid fluid and condensation process. The last one is boundary layer along a material handling conveyor. Okay, so these are the applications we have. Thank you, sir.
Any question? Okay.
Thank you.
Next participant. Okay, thank
Thank
you.
you,
Thank
Sharavana
you very
sir.
much.
Next participant is Sanila Mary Davis, Department of Mathematics, St. Thomas College, Thrissur. Topic is nanofluids and applications. Welcome, Sanila Mary Davis, for the
Hello.
presentation.
Hello, sir. Hello, sir.
Okay.
Is I audible?
Yes, yes, you are audible.
Yes.
My name is Sandra Medhus. I'm second year mathematics student. Here I'm going to discussing about nanofluids and its some applications. So we know that there are different types of fluids are there in our nature. They are basically used as the heat carriers in the heat transfer applications. But the main limitation of the fluids are the low thermal conductivity. So in 1995, they developed a newly innovative class of heat transfer fluids and called it as nanofluids. So basically, we know that a substance which has the property of flowing is defined as a fluid, and in a particle which has the size smaller than 100 nanometer is known as nanoparticle. So nanofluids are fluids which consist of these nanoparticles, and they are occurred by suspending these nanoparticles in a fluid medium such as water, oil, ethylene glycogen, etc. And these nanoparticles are mainly made up of metal oxides, carbides, or carbon nanotubes, etc. We know that fluids have a main limitation. The main limitation of the fluids are the low thermal conductivity. And nanofluids can overcome these main limitations because of the great thermal physical properties such as thermal conductivity, thermal diffusivity, viscosity, and heat transfer coefficients compared to the base fluids. Therefore, we can say that nanofluids has a key feature. The key feature of the nanofluids is its super thermal conductivity, and also by varying the size of the particles, the conductivity of nanofluids can be controlled. And only by the chemical solution method, it is enable us to design, it is enable us to make a production of efficient nanofluids with controllable microstructures. And there are two types of preparation for the nanofluid. One is one-step method, another one is two-step method. In two-step method, the nanoparticles, nanofibers or nanomaterials which we use here as a dry powders were produced by physical or chemical process. And after that, directly displace these nano-sized powders into fluids with the help of intensive magnetic force agitation, ultrasonic agitation, etc. And after that, this is a main commonly used method, and also this is a most economic method to produce nanofluids at large scale. And there are some difficulties for the preparation of the stable nanofluids by two-step method. To overcome these problems, they introduce one-step method. One-step method is a method making and dispersing the particles simultaneously is the process of one-step method. In this method, agglomeration of nanoparticles is minimized by avoiding the drying, storage, transportation, and dispersion of nanoparticles. Thus, the stability of the nanoparticles is increased. But in two-step method, it is very difficult to produce stable nanofluids. Because of these reasons, in one-step method, it is very easy to produce stable nanofluids. So, the limitations of two-step method can be overcome by one-step method. And now I am discussing about the some applications of nanofluids. Nowadays, we know that most of the industrial process contains transfer of heat energy. And also, the most major task of the industrial necessity is the process of removing, adding heat to the industrial facility or to move from one stream of process to another. So the main application of the nanofluids are the cooling applications. Here I am discussing about the cooling applications of nanofluids. First one is the crystal silicon mirror cooling. We know that crystal silicon mirrors are used in the high intensity X-ray sources, And one of the most important applications of nanofluids is the developing and advancing cooling technology to cool these crystalline silicon mirrors. And there so many experiments and observations are conducted, and they reached in a results that nanofluids can remarkably reduce the thermal resistance and increase the power densities. And this is an advanced and effective cooling technology compared to others because of the micro channels that used here will give an effective heat transfer area, and the metallic nanoparticles used here will increase the effective thermal conductivity of coolants. The advanced cooling technology may be used in cooling engines, superconducting magnets, and densely packed computations. Another application is the electronics cool. In 2003 was the first we experimented that the thermal performance of heat pipes can be enhanced nearly by a factor of 2 when nanofluids are used. For that they used water-based nanofluids containing 17 nm gold nanoparticles as a working fluid in a disc-shaped miniature heat pipe. And they also measured the thermal resistance of disc-shaped miniature heat pipe with both nanofluids and also with deionized water. Thus, this result shows that the thermal resistance of a disc-shaped miniature heat pipe is reduced significantly, about 40%, when nanofluids are used instead of deionized water. And also, the next application is the vehicle cooling. This application is a very remarkable one because this is an daily life, real life application. So nanoparticles can disperse in coolants, we know that, and also in the engine oil. But nanoparticles can also disperse into the transmission fluids, gear oils, and other fluids, and also the lubricants. And in 2005, it was probably the first to apply nanofluids in a real world application. For that, they dispersed copper oxide and aluminum oxide nanoparticles into automatic transmission oil. And for that, the experimental platform for the is a real rotary blade coupling. And they also measured the temperature distribution of the real rotary blade coupling for the different rotating speed, and the result shows that the copper oxide nanofluids have the lowest temperature distribution at both high and low rotating speed, and accordingly the best heat transfer effect. This work is important because it is real world application of nanofluids, and this makes a big step forward for the industrial applications of nanofluids. And the next one is transformer cooling. Transformer cooling is an application of nanofluids for reduces the size and weight of the transformer. Because of this reason, power generation industry is very interested in this application. And also in 2000 and 2007, so many of them are demonstrated that the heat transfer properties of transformer oil can be improved by using nanoparticle additives. And the last one is a defense application. There are a number of military devices and systems such as military electronics, military vehicle components, radars, and lasers which need which needs a high heat flux cooling. And using the conventional heat transfer flux for the cooling is so difficult because of the limited capability of current heat transfer fluids. Cooling of direct energy weapon and associated power electronics are critical. But nanofluids can overcome this problem. Thus, nanofluids provide cooling technology for defense applications also. In the conclusion, nanofluids has various exciting applications in science and technology because of the small size of the particles. It can be applied in, because of that reasons, it can be applied in various fields. Nanofluids research gives a way to developing next generation coolants for numerous engineering applications.
Any questions? സെന്റർ ഒന്ന് വീഡിയോയിൽ വരണേ. ബാക്ക്ഗ്രൗണ്ടിൽ ഇരുന്ന് പ്രസന്റ് ചെയ്താൽ ശരിയാവില്ലല്ലോ. പ്രസന്റ് ചെയ്യുന്ന ആൾക്കാർ വീഡിയോയിൽ വരണം, അല്ലെങ്കിൽ അത് ഒന്നാമത് വെർച്വൽ കോൺഫറൻസ് ആണ്, ആളെ കാണാതെ പ്രസന്റ് ചെയ്ത് കഴിഞ്ഞാൽ നേരത്തെ വന്നിട്ട് പോയതാണോ അല്ലേ? ഇതിനകത്ത് മാത്തമാറ്റിക്സ് പാർട്ടൊന്നും അധികം ഇല്ല അല്ലേ? പ്രസന്റ് ചെയ്തതിൽ അപ്ലിക്കേഷൻസ് ആണെങ്കിലും മാത്തമാറ്റിക്സ് ഒന്നും അപ്ലൈ ചെയ്തുള്ള റിസൾട്ടിലൊന്നും വന്നിട്ടില്ലല്ലോ അല്ലേ? അത് ഇല്ല. ഓക്കെ, തുടങ്ങിയതേ ഉള്ളോ അതോ സ്റ്റേജ് ആയോ? റിസർച്ച് എങ്ങനെയാണ്, ബിഗിനിങ് സ്റ്റേജ് ആണോ അതോ?
ഇല്ല, ഞാൻ PG ചെയ്തോണ്ടിരിക്കുന്നു.
PG ആണോ? ഓക്കെ, PG സ്റ്റുഡന്റ് ആണ്. ഓക്കെ, കൺഗ്രാജുലേഷൻ. Okay, pass over to next presenter, next candidate. Thank you.
Hearty welcome to our dear HOD sir, Dr. Saju M.I. sir, he has joined us. Hearty welcome, sir. We invite the next presenter.
Okay, thank you.
Welcome, Saju sir. Next presenter is Father Jolly Andrews, Assistant Professor, Christ College, Iringalakkoda. His topic is mathematical modeling of superconducting transmission lines using spectral domain methodology. Welcome, Father Jolly Andrews, sir.
Audible. Okay, thank you so much. And I think, yeah, fine, thank you. Dr. Paul Isaac, the session chair, Dr. Saju, the HOD of the Department of St. Thomas, Dr. Sister Julie Andrews, the convener of the conference. I am Father Dr. Jolly Andrews, along with Dr. VP Joseph, presenting mathematical modeling of superconducting transmission lines using spectral domain methodology. So here, to make a small introduction about the what the modeling is going about, vortex effects in high temperature superconducting material. They are superconducting materials. They are high temperature superconducting materials, but they when an external magnetic field, there will be vortices. Vortices are magnetic lines which will be passing through the magnetic material, passing through the superconducting material. They are vortices. They are magnetic lines which are passing through it. So the next point I want to make here is the transmission line structures. Especially we will be using the inhomogeneous waveguide structures which will be carrying the microwave signal. I'll be explaining what is this inhomogeneity. The objective of the study is to develop a modeling technology for various microwave high temperature superconducting inhomogeneous transmission lines, addressing the device simulation issues and model the propagation parameters of microwave high temperature superconducting transmission lines. Inhomogeneity means usually in the transmission lines, as you can just see here, we place a small conductor on the top. If you have the same area, same length and breadth as there in the lower side, then that will be homogeneity. But here you have got the area is higher area, then you have got a dielectric material, they got a small strip, the area of the conductor is small. So for mathematical modeling of such kind of strips are not that is not that very easy. That's a point which we have to address here. So the analytical solution for such types of materials are not that easy. We have to go for numerical solution. These are some types of transmission lines. Here we will be speaking about microstrip lines. Microstrip lines are the widely used printed circuit lines and easily adaptable to hybrid and monolithic IC fabrication technique and compact and light in weight. Why we have to use superconductors here? So this is what I said. The microstrip line, the cross section of the line, downward you have got a metallic strip, or you can have a superconductor here. On the top you have got high temperature superconducting film there of very low thickness, and here in between you got a substrate. And if you are replacing normal metal with high temperature superconducting film, then we have got low loss and low dispersion that will help a better signal fidelity. And this is very compact microwave device that, like filters, can be easily also fabricated by using these high temperature superconducting microstrip transmission lines. Now the industry is always looking for the simulated results, the mathematical modeling results, and then only they will look for the actual physical manufacturing of such types of transmission lines. So we have to do the simulation works. Hence the importance of these types of study. Word about high temperature superconductors, they are all about higher than liquid nitrogen temperature. And some examples will be YBCO, DBCO, BSCCO, and they've got a lot many potential applications in different fields. Now, the modeling aspects, the oldest modeling aspects of a superconductor is a two-fluid model by Gotter and Casimir in 1936, which means in a superconductor, there is a superconducting part, there is a normal part. So you are speaking of both these mediums are non-interacting mediums and having a superposition of them. So here we had to study about the vortex dynamics before here, because these normal part will be carrying the magnetic lines there, and these magnetic lines, as I said, high temperature superconductors are extreme type 2 materials of superconductors. There will be Lorentz force there because of the applied field. These magnetic field lines will be moving, so Lorentz force comes there. Viscous drag force will be also there. You can pin these vortices, so pinning force should be also taken into consideration there. So the total current density will be because of all these different types of magnetic fields which are associated there. So one vortex modeling was made by Gittelman and Russelberg, but they neglected the motion of the vortices. Then came the Coffee Club model. They included this thermal and flux model. This is a path breaking paper as far as this Coffee Club model has been said in a physical review paper. Now, the Coffee Club model gives the London penetration depth in terms of three particular lengths. The first length is lambda. I would say the first length will be effective vortex skin depth. It is defined in this particular manner. Then comes the dynamic mobility term mu v, which is also defined in this particular manner. I'm not going depth into it. And now comes to the modeling technique. Modeling technique we use is spectral domain methodology. It is an analytical method and is very efficient for inhomogeneous transmission lines that has been proposed by ITRA and MITRA. And basically this is a Fourier space analysis. It's known for its mathematical compactness and computational adaptability. So in a space domain, we have got coupled homogeneous integral equations. What you do is we have to make a Fourier transformation of it. You get a coupled homogeneous integral equation in the Fourier domain in this particular manner. Then we match the electromagnetic boundary conditions. So very painstaking. I'm not putting all the complex equations there. I got the paper also here. Then you will get the basic equation, basic Ohm's law equation in the matrix form is presented here. Said is an impedance, J is the current terms, and E is the electric field terms here. Now, what you're going to do is you are expanding the unknown current terms in terms of the basis function. So you can select the basis function here. It's a Galerkin technique. You can select the basis function, a particular way where the boundary conditions are matched. Now you take the inner product of the matrix equation with the basis function. Current and fleet components are 0 in the complementary region. On the strip, you will have the current. As the field will be 0. The other area you have the current as 0, but the field will be maximum. So taking it that particular manner and applying this Galerkin technique and thinking only about one basis for a current component, you get the equation in this particular manner. Now, this is the basic HTS microstrip. This is about a normal strip. This equation is for a normal strip. But now we are going to replace this normal strip with a high temperature superconducting strip. Then the electric field will be, I would say, will be modified in this particular manner, which means our algebraic equation will be again modified, where G can be defined in this particular manner, where G is a new impedance term. So now the basic computation methodology is this: the Coffee Club model. From it, you'll get the complex conductivity, and by using the technique that has been advanced by Pond, you'll get the surface impedance. Vincent is our group. He was my PhD guide when I was doing my PhD under Dr. Vincent Matthew. We have developed the this spectral domain Green's function formulation technology, and by using the method that has been proposed by Ito, by following the Galerkin technique, by using the we calculate the propagation parameters, the attenuation and the attenuation and the parameters, propagation parameters of the high temperature superconducting line. So that was about the microstrip line. We did also about the slot line. Slot line is I would say, complementary part of a microstrip. Here, this is slot line. Earlier microstrip, in this particular area, you had got the high temperature superconducting film. Slot means there's an empty space in between, and you place the HTS films on the other two parts, on the boundary area, on left and right of that slot. So again, we use a spectral domain formulation, but here we will be using, instead of the impedance matrix, we use the admittance matrix. So dyadic Green's functions is formulated in this particular manner, and the electric field is expanded in this particular manner itself, and the matrix will be redefined in this particular manner. One difference that you can see is mainly that the procedure is same here, but here, instead of expanding the current terms, what we'll be expanding is the electric field term. We'll be applying the basis function, expanding the basis function to the electric field instead of the current terms, because the current area, the area where there is current, the slot area will be more, whereas the empty slot area will be lower. So we will be expanding the field components here. The field components are expanded here as a basis function here. So in the similar procedure, we take the inner product and get the propagation parameters. This is a coplanar waveguide. This is nothing but, I would say, the mathematical modeling could be, this is not just one slot line, it combines some slots, two slots are here. You can have more number of slots, add up to it, you can have a coplanar waveguide. So this you have got a wide variety of applications also. It can be treated as a coupled slot line in the particular case which I treated here, where E over the slots are not symmetrical at the center of each slot. So adding the even basis function of EZ and odd basis function for EXS, that we have got three basis function here, and the HTS contribution is computed just as in the case of a slot line. And the procedure has been has been proposed by Ito and Mitra. We get a 3x3 cross matrix, and you do the same thing here. The same procedure which I explained here, we will do it. So before we do the actual, we have to write all the programming part of it. This is spectral domain part of it, and also make the part of the superconducting programming part also has to do. These are some of the parameters when you do the computation. The H is the height, A0 is the inter-vortex distance, the lambda is the London penetration depth, H by lambda. These are all the parameters that you should take. Some of the parameters which are taken here are also shown here for doing the computation part. These are the results, and the results are as in the expected line. You can find at higher H, as you got a higher thickness H, we have got a higher at a fixed H, H is fixed on the x-axis. We have got the height H the thickness. On the y-axis, we have got a phase constant. For a higher value, the magnetic field is applied. B is the reduced field value. B is equal to 0.025, 0.05, and B is equal to 0.075. These are reduced field values. So when we take it, you find for a higher field value, got a higher phase constant, but the values are almost constant. They're not changing with respect to H. There's not very great change as with respect to the strength of the magnetic field also. These actual field values will be around 2.4 Tesla, 5.6 Tesla, and I think 8.4 Tesla, if I remember from my memory. Now, when you look into the attenuation part, whether the wave is attenuated or not, we can find as the thickness is enhancing, as the H is enhancing, we have got the attenuation decreasing. At a fixed H, as a magnetic field is increasing, there will be a higher value of attenuation. So if you got a higher value of H, lower value of the magnetic field, you got lower value of attenuation, which means you will have a better signal fidelity. The same, okay.
It's
Yeah, it's
time,
okay. I come
dear
to
father,
the
it's
list of the
time.
publications, which some of I have, and thank you so much. I think I have finished it. Thank you so much.
Okay, any question?
Sir, I have a question.
Okay.
In the video, a pinning force.
Okay.
I see a pinning force.
Okay.
Who is asking the question?
Yeah.
What is a pinning force? I
Pinning
see.
force means when you look into the physics of vortex motion, these magnetic lines are not stationary inside a high temperature superconductor. These vortex line can move, especially when there is these vortex lines are magnetic lines, especially when they are placed inside an external magnetic field. These vortex lines can move. They can move zigzag. They can have a movement. So there are certain techniques whereby we can pin these types of moment of the vortices. So you can pin those vortices with the help of electromagnetic force. Some crystal defects can pin them. So you have to take into account how much a vortex can be pinned into a particular area, by which you can have it kind of a potential well, and inside that potential well you can pin it down. So think about that potential well, the depth of that potential well, whether you are able to pin it down, then you can have a better result as far as the signal fidelity has been concerned. That is why we have to include this pinning force also. I think I given a rough description of the question which I asked.
Okay, I have a doubt. Is it
Okay.
depends on a fluid particle or a fluid molecule?
Who is asking the question? He is not
Yes.
on the video.
Okay.
Sabu sir
Okay,
is
okay, okay,
asking.
okay.
He's just coming.
Sir,
Okay,
I
sir.
have a doubt. It depends on
Okay.
the entire fluid, or it depends only on the fluid particle.
No, the
Material.
thing is that we are taking it in comprehensively. The entire thing has been taken together as far as the vortex physics has been concerned. The modeling aspects is being defined by the coffee club model, which we have taken here. So it depends upon the penetration depths and some parameters like penetration depth, parameters like del VC, the penetration, the parameters like dynamic mobility term, which comes as an effect of the entire thing. So as to take it as a macroscopic level rather than in a microscopic level. I think I
Yes.
have answered you.
Okay, I understand. Okay, thank you for.
Thank you.
So thanks a lot,
Okay.
dear father, for your presentation. I'm extremely happy to extend my congratulations and gratitude for you as my dear brother and also as the principal of Christ College. And Saju sir is also here with us for this session. Thanks a lot. Dr. Paul Isaac sir, actually, I was requesting yesterday night to have this presentation in father's convenient time. So thanks a lot, Paul Isaac sir. Thank you, sir.
Thank you for the Dr. Paul Isaac and Dr. Saju, and best wishes to Dr. Sister Julie also. Thank you so much.
Okay, thank you.
Thank you, Father.
Thank you. Thank you.
Glory Andrews. Next. Thank you, Father. Next presenter is Sneha Sylvester, Assistant Professor, St. Thomas College, Thrissur. The topic is emerging role of cloud encryption among corporates. Welcome, Sneha Sylvester, for the presentation.
This will not take more than 7 minutes for presentation and 3 minutes for questions. It will not take more than 7 minutes.
My voice is audible.
Connectivity problem.
There is a connectivity problem.
There is a connectivity problem, it seems. Oh, okay.
Okay.
Okay, sir.
Okay, good evening, sir.
Maybe.
Good evening. Okay.
Please present your matter in 7 minutes. Please start.
Okay. Is my slides are visible?
No, it is not visible.
Share it first.
Hello, sir. There is some technical problem which is happening in between. Our technician is trying to correct it. There is some internet problem with the system. Sorry for the interruption. All of you kindly bear with.
Is it visible, sir?
No, not
Can
visible.
see you, but not presentation.
Please share your screen.
Yes, അതെ അതെ അല്ല ഞാനാണ് മിസ്
It is the problem from the Please present, Sneha.
Okay. So, good evening. My topic is emerging role of cloud encryption among corporates. Okay, myself Sneha Sylvester, Assistant Professor, St. Thomas College,
One
Thrissur.
minute. Slide is not visible. Share screen എന്ന് press ചെയ്യൂ. സ്ക്രീൻ പ്രസന്റ് ചെയ്തിട്ടില്ല. Okay. Now it is okay.
Sir, is it visible?
No, it is. Please share. Please choose the window. Okay.
Okay.
Now it is visible.
Okay. So, okay. Good evening, everyone. Myself, Sneha Sylvester, Assistant Professor, St. Thomas College, Department of Commerce and Management Studies. I am presenting this paper along with Ms. Alice N.K., our HOD, Department of Management Studies, St. Thomas College, Thrissur. My topic is emerging role of cloud encryption among corporates. So, let's start with an introduction. Online data security has been one of the prominent issues faced by corporates today. One of the most effective tools to protect data is cloud encryption. Using this cloud encryption, anyone is able to log in anywhere with the internet access to upload and retrieve their data. So let's move to what is cloud encryption. First, encryption, it is defined as the translation of data into a secret code. The cloud encryption is the process of encoding or transforming data before it is transferred to cloud storage. Encryption uses mathematical algorithm to transform data to an unreadable form that can conceal it from unauthorized and malicious users. So there are various methods for cloud encryption. There are mainly two methods, symmetric algorithm and asymmetric algorithm. In symmetric algorithm, encryption and decryption keys are the same and which make the use for best for closed system and individual users. And these two keys are used to secure communication. And in asymmetric algorithm, two keys are used. That means the private key and public key. In this case, the private key must be kept as hidden and secret, and the public key can be shared with anyone. And the cloud encryption is needed because its main aim is to secure and protect confidential information. Information technology mainly focus on the availability of data and its integrity. Information technology does not give enough thought on the data confidentiality. This is why cloud encryption should be used by any organization. So next is the objective of my study. The main objective of our study is to find out the major business problems to be solved with the help of implementing cloud encryption. So next is analysis and interpretation. Encryption is an effective method of protecting the corporate data, and leaving the company data unencrypted on the company network is the equivalent of leaving your business doors unlocked and all of the cash from the week in the register. And next is the major business problem solved by adopting data encryption. First is the importance of data and where it is stored. And this problem can be solved with the help of cloud, and the cloud can provide a more flexible option for storing data. Next is the hosting problem. The cost-effective cloud option will help mitigate the risk associated with the long-term investment or expensive migrations. And the next issue is security. The cloud technology has advanced greatly, and now it is actually more secure and reliable than the traditional on-premise solution. The fourth issue is vulnerability to disasters. The cloud platform creates another layer of protection in the event of disaster. And the fifth is benefit for disaster recovery. Supporting disaster recovery efforts is one of the important advantages of cloud computing for companies. And the sixth issue is increase the long-term cost. By using the hybrid approach of combining cloud services and the local dedicated servers, you can ensure you are not paying for more storage than you needed. Next issue is boost the cost efficiency. And the cloud platform reduces or eliminates the need for businesses to purchase equipment and build out and operate data centers. Next is the flexibility, lack of flexibility with the cloud. However, user can bring their data with them wherever they go. Next is reduced agility. The ability to scale up or down can be critical for the business to stay agile and competitive. Last issue is limited technical support. And this risk is reduced in the cloud because you will have the built-in support for experienced professionals, and you will not you will not have to rely on anyone with minimal experience. And the conclusion, not to conclude, encryption is the process through which the data is protected from unwanted eyes. Encryption is the most effective form of data security, but unfortunately, it is also an area that very few people know how to approach. The inability to protect data can destroy a company's reputation, and no one wants to work with an organization that may allow sensitive information to fall into the wrong hands. Okay, thank you.
Any questions? Okay, thank you. Thank you very much for my discussion.
Thank you, Sneha Miss. Next
one.
presenter is Arilakshmi CD, Department of Mathematics, St. Thomas College, Autonomous, Thrissur. The topic is nanofluids and applications. Welcome, Arilakshmi, for the presentation.
Good evening, everyone. Is my slide is visible?
Yes, visible.
I'm Arilakshmi CD. I'm doing my MSc in Mathematics at St. Thomas College, Thrissur. My topic is nanofluids and applications. The dispersion of nanoparticles in fluids results in stable suspension called nanofluids. Metals, carbides, oocytes, etc., are used as nanoparticles in nanofluids. Nanofluids possess several unique properties like thermal conductivity, thermal diffusivity, etc. Due to this, they are used in various fields in order to increase the output of many systems. So, in this paper, we discuss about some of the applications of nanofluids. So, these are the keywords. Now we go to introduction. Today, our science and technology has many advancements and new inventions are made day by day. In this scientific era, scientists are in search of inventions which are smaller in dimension and highly efficient in performance to save space and time. When the dimensions of these equipments become smaller, the heat floods associated with it becomes larger. So there arises the necessity for improving our cooling technology. But the cooling fluids which are available are poor conductors of heat. So we need to design fluids which are good conductors of heat. In order to increase conductivity, powdered particles are added to fluids. So it causes the settling of particles, and in order to prevent settling, additional efforts are made to stir the mixture continuously. The search for more efficient fluid led to the invention of nanofluids. Nanofluids are formed by suspending nanoparticles which are less than 100 nanometer in size in traditional fluids such as water, oil, ethylene glycol, etc. The unique thermal, physical, optical, magnetic properties of nanoparticles adds to the efficiency of nanofluids. The term nanofluid is coined by Stephen U.S. Choi in 1995. Nanofluids are designed to achieve the highest possible thermal properties at the smallest possible concentrations by the uniform dispersion and stability of suspended nanoparticles in host fluids. Nanofluids Nanoparticles used in nanofluids are of different materials such as oxide ceramics, nitric ceramics, etc. These nanofluids are formed by two-step and single-step production method. In two-step production method, the nanoparticles are produced first, then they are dispersed in the host fluids. And in single-step method, the production of nanoparticles and the dispersion takes place simultaneously. Now, applications. Nanofluids are designed as a heat transfer fluid with uniform distribution of nanometer-sized particles in liquids to form stable suspensions. The most important application of nanofluids is the application in thermal management of industrial and consumer products. They are very dilute concentration of nanoparticles in fluids. So the increase in the surface area of these particles enhances the heat transfer, and thereby they became as a coolant. Nanofluids play its key role in the world of science and technology. The applications we discuss here are tribological applications, biomedical applications, applications in solar energy. Tribological application. Nanofluids are used to develop better lubricants and oils. The tribological properties of lubricants, such as load carrying capacity, anti wear, and friction reducing properties between the moving mechanical components, are enhanced by the use of nanoparticles in lubricants. In this application, it is observed that surface modified nanoparticles stably dispersed in mineral oils are very effective in reducing wear and tear and increasing the load carrying capacity. Experiments were conducted in nanofluids containing nanoparticles such as zirconium dioxide and iridium dioxide. These experiments led to the result that these lubricant nanofluids reduced friction considerably on the surface of 100 cc steel. Now, biomedical application. Nanofluids are now developed for medical applications, especially in cancer therapy. The traditional methods for cancer treatment, such as chemotherapy, has certain side effects. Iron-based nanoparticles can be used as scavengers for drugs or radiation without damaging the nearby healthy tissue by guiding the particles up the bloodstream to a tumor with magnets. Magnetic nanoparticles are more adhesive to tumor cells, so they absorb much more power than the microparticles in alternating current magnetic fields tolerable in human. Nanofluids are used in nano drug delivery system because they are too small in the size, so when they arrive at the surface of living cell, they absorb them frequently. Nanofluids also helps in surgery by cooling the surgical portion and thereby helping the patients, reducing the risk of organ damage and saving the patient's life or increasing the chance of survival. Nanofluids are involved in biomedical applications such as magnetic cell separation, drug delivery, hyperthermia, and contrast enhancement in magnetic resonance imaging. Surface coating of nanoparticles and the colloidal stability of biocompatible water-based magnetic nanofluid are the two factors that affect the successful application of nanofluids. In contrast with cooling, nanofluids can also be used to produce higher temperature around the tumor to kill the cancerous cells without affecting nearby healthy cells. Applications in solar energy. The solar energy from the rays of sun are directly converted to electrical energy. Nanofluids as a potential heat transfer fluid can effectively increase the thermal performance of solar devices. Nanoparticles act as the absorption medium, allowing nanofluid to directly absorb solar energy. In collectors and solar water heaters, the thermal performance of nanofluids are used. Nanofluids enhances the development of solar energy system. Then other areas of application of nanofluid technology include cooling small computers and electronic devices which are used in military system, airplanes, spacecrafts. As a fluid superconductor, nanofluids could be used as a working fluid to extract energy from Earth's core and produce large-scale energies in power plant system. It is shown that the combustion of diesel fuel mixed with aqueous aluminum nanofluid increased the total combustion heat while decreasing the nitric oxide and smoke in the exhaust of the automobile diesel engine. Conclusion: nanofluids are important because they have various applications in heat transfer and biomedicine and so on. As a coolant, nanofluid plays key role in the world of science and technology. They are used in their biomedical applications are so effective, so they can be used in biomedical engineering, biosciences, etc. Their tribological applications in biomedicine, applications in solar energy are very well defined. The growth of nanofluids in the last 2 decades is the evidence that in the progression of science and technology, these colloidal suspensions has an inevitable service. References. Thank you.
Any questions? So please pass out.
Thank you. Thank you very much, Arile.
How many
Only
remains,
two.
sir?
Only two.
Only one.
Two remaining.
Mine going. The given list only one. Just tell the other person.
Okay. Our next presenter is Lijo Jos, Assistant Professor, Department of Commerce, St. Thomas College Autonomous Thrissur. His topic is two important application of mathematics in investment decision making. Welcome, Lijo sir, for the presentation.
That document is not sent to me.
Excuse me, sir. I think I had sent it yesterday night, sir.
In WhatsApp or in mail?
In your
Mail is
WhatsApp,
not-
sir.
WhatsApp maybe there. Okay, just present it. Please present it. No problem.
Lijo sir, now present. Lijo sir, please present. Lijo sir, please unmute. Lijo sir, please unmute.
Yeah, I'm trying. Okay, is now audible? Am I audible?
Yes.
Hello?
Yes,
Okay,
audible.
Okay. So I am starting my topic. Okay, in my presentation, I will try to introduce two mathematical applications, which is very helpful for while investment decision making. The first point is, as time is very valuable. Time is very valuable. I am telling that the money has a time. Money has a time, which means the money has a time value. What is meant by money has a time value? The value of money depends upon time. That is, the correct implication of time value of money is very clear from the English proverb, "A bird in hand is worth more than two." For example, if an individual is given an option to receive rupees thousands today or to receive the same amount after 1 year, he will definitely choose to receive the amount today. The reason why he prefers to receive money today is that the money received today has a higher value. So it is known as time value of money. So the money has the time value. So what is the benefit of understanding this? For that, I would like to use two concepts: the future value of money and the present value of money. But first, I am talking about the future value of money. What is meant by a future value of money? Investors need to know what the future value of their investment will be after a certain period of time, calculated based on an assumed growth rate. For instance, rupees 1,000 investment will be after 2 years.
Sound is not clear.
Lijo sir,
Problem with the sound.
audio is not clear. Lijo sir, audio is not clear.
Anyway, you continue. We can read the matter.
Please switch off your video. Then audio more better.
Can you please continue? We can read the matter.
Before you would like to know what will be my future return, or what is the amount I will get in the future. So the future value of amount now you are spending. Let's see an example. Finding out. Just imagine that you are putting rupees 100 today, and you would like to know what will be the value of rupees 100 5 years and rate of 5% interest rate. That means you are investing 100 rupees today at the rate of 5%, and you would like to know what will be the future value of your 100 rupee after 5 years. Normally, a rational man can make a calculation like this. This is compounding calculation. That is, you are putting the money and you're getting the interest, and you are again putting the interest into that until completing the 5 year. So in the first year, the amount you are putting is 100 plus you will get a 5% rate of return. Then your investment grow up to 105. And again, in the second year, your value is 105 plus you will get the 5% interest on 105. Like this is a compounding method. After 5 years, you can find out, or you will know that the amount or the future value of this 100 will be rupees 127. So when before you are making an investment, you are able to calculate the amount that will be getting after 5 years, that is rupees 127. So this mathematical formula is helpful to calculate the future value of your present investment. Another formula, when we are using the actual future value formula, that is present value is equal to future value divided by 1 plus r raised to n. Like future value calculation, we can calculate the present value also. How we can calculate the present value? That is, the formula is future value divided by 1 plus r raised to n. Okay, let's see how this formula is. Just stressing that I will give you 1,000 rupees after 4 years, like 8% interest rate, and I am asking you give me 800. Okay, now I am asking you give me an 800. I will give you 1,000 after 4 years. The present market rate or the present bank rate is 8%. So now you can calculate to get 4,000 in 8% interest rate. What would I have to invest now? You can calculate the intrinsic value. When you are applying this formula and finding out the present value of this future sum, you are getting the present value of this sum is rupees 735 only. But I asked you give me an 800 rupees. So it is not advisable for an investment because actually it has a 735 rupees present value only. So in such a way, we can calculate the present value and we can calculate the future value by applying this mathematical formula, which is very helpful while making an investment decision. So let me conclude. It is evident that mathematical methods and tools become crucial part of the investment decision making. Mathematical formula help investors to forecast their return and to choose good investment opportunities. It also helps to avoid investment in overpriced securities and to protect the selling of securities from underpriced. In the light of the above, I conclude that knowledge of mathematics is very helpful to take good investment decisions. Okay, thank you.
Any questions?
No question.
Okay, thank you. Thank you very much for this.
Okay, thank you,
Last
sir.
one.
Thank you for all.
Last
Thank
one.
you. Thank you, Lijo sir. Next presenter is Ashik Joseph, Department of Statistics, St. Thomas College, Thrissur. His topic is Applications of Mathematics. Welcome, Ashik Joseph, for the presentation.
Good evening to all. I am Ashik Joseph, UG first year student of St. Thomas College. Yesterday we see some of the mathematics topics in mathematics. Today we can see some of the
Ashik, excuse me, Ashik, please on your video.
Okay.
Okay.
Good evening to all. I am Ashik Joseph. I am a first year student of St. Thomas College. Yesterday and today we see some of the topics in mathematics. My topic is the applications of mathematics. Let me discuss about some of it. First, we can say the mathematics discussed in school and work. Students can't avoid mathematics in their school life. However, even like history and English language, they require little knowledge on math. They will most helpful to them. In work, even hourly will needed to know if their working hours multiplied by their rate of pay accurately reflected in their paychecks. Next, mathematics in finance. The use of mathematics within the field of finance has been increasing substantially in the past, and such as trend is expected to continue. Various type of organizations and financial service providers utilize financial mathematics as part of their core operations. Mathematics in material science. Mathematical techniques necessary for understanding of materials science topics such as energetics, material structure and symmetry, material response to applied fields, mechanics, and physics of solids and soft materials. Mathematics in biology. Most of the biology students will be know the Gregor Mendel in their +1 biology textbook. First paper, the Rod Mendel on the discovery of Mendelian laws is mathematics of peace. John Perry has correctly estimated the values of mathematics in the study of natural science by saying, in these days, all men ought to study natural sciences such as studies practically impossible without the knowledge of higher mathematical methods. In the defense mechanism, mathematics in army, the USA Army could not bring heavy tanks in the time and helicopters were not used to avoid casualty. Also, there is a need for little systems which same for improved requirement as before. We see it as in some of the English films, they aiming the enemies to in the angle. It will help. The max will helpful to aiming the enemies. Mathematics in banking. Mathematics affect the financial decisions that we make every day. For paying our bills to using coupons at the grocery store, math is a part of our everyday lives. Number sense and a facility with mathematical concepts is especially useful in banking. We use math for budgeting, spending, saving, and investing. We are familiar with the mathematics in kitchen in making teas, like counting the number of teaspoons of sugar that are just right for your in your tea or coffee or complicated cooking and baking. Even just using the stove, microwave, kettle is basic mathematics skills in their action. At last, in the mathematics in agriculture, mathematics plays a very important role in agriculture and is vital to all farmers alike. Some examples of applications of mathematics in agriculture are measuring soil fertility, estimating crop yield, calculating cost and profits, conversion of units, measurement of areas. Agriculturalists also use number of grade and describe seeds. Math in soil analysis. Knowledge of mathematics is very important for the analysis of the soil. It is required to measure the moisture and acidity of the soil. These measurements will allow the farmers to decide what kind of crops he can grow in this field, or even what kind of fertilizers he should use. Farmers use maths which apply chemicals and fertilizers to the soil. They need to measure how fertilized the soil is, how much fertilizer is required, and how much it is will cost. In the conclusion, in this presentation, we see the various applications of maths in the academics and besides academics. It's almost impossible to get through a day without using maths in some way because our world is full of members to handle and problems to solve. Studying the maths in everyday life provides you with the tools to make sense of it all, making life that you little bit easier. Thank you for all hearing.
Thank you. Thank you.
Thank you, Ashik.
I think all questions
Finished,
are
sir.
over. Thank you. Thank you very much. So, shall I leave now?
Once again, sir, just a note of thanks by Sabu AS, our assistant professor and technical session convener. Over to Sabu.
Good evening to all. Today's paper presentation was handled by Dr. Paul Isaac sir, Bharat Mata College, Kakara. His area specialization is Lie algebra, applications of fuzzy sets, rough sets, etc. I extend a hearty vote of thanks to Dr. Paul Isaac sir, who chaired and spared time from his busiest schedule to this occasion. My gratitude to HOD for the support of the program. My gratitude to Dr. Julie Andrews, convener of this program, Professor Ranjit Varghese, technical assistant, and gratitude to all the presenters. I also extend thanks to all the staff members and participants for their support and cooperation with this program. Once again, thank you to all.
Okay, thank you all.
Officially we are ending the session, and tomorrow we will join live session as ending now. Thank you all.
Thank you.
Thank you, Apologies, sir. Thank you.
Thank you for